probabilities, yeah, the prior a priori probabilities and the posteriori probabilities. Yeah, we already practiced also last week. In decision tree, the models developed by the machine learning methods, this will be a tree, yeah, a tree. Why it is called a tree? Yeah, because we have what is called root. Yeah, the node, the node in the top of this picture, it is called root. Yeah, this root, just like a tree. A tree has root, right? Root. This has root. Yeah, and the root will have the children. Have the children. The root have the children, and every internal node also have a children. Yeah? So the training data is used by the decision tree induction method, yeah, to create the tree, to create the tree like this, yeah, to create the tree like this. And then when the machine learning algorithms develop the tree, the model like this, then this tree can be used for predicting something, yeah, for predicting something. So for example, last week we already learned some training data in for the naive Bayes. Yeah, wait a minute. This one, right? Yeah, we have the X here. There is one customer, yeah, called X. This X has age less than or equal 30. The income value is medium. And he is or she is student, yes. And the credit rating fair. The computers want to predict whether X will buy a computer or not. Yeah? Will buy a computer or not. So remember last week example. So what is the decision from the naive Bayes algorithms? This X will buy a computer or not? All of you, please answer my question. This X will buy a computer or not? This last week example.
Yes.
Will buy a computer or not?
Will buy.
Bye,
Yes.
sir.
Yes, sir.
We'll buy the
Yes,
computer.
sir. Will buy
Yes.
the
Will buy a
computers.
computer, right? Yeah. We already computed, right? The probability 0.007, right? Yeah. And the probability of X by a computer is 0.028. So the probability of X by a computer is greater than the probability X not by a computer. So the conclusion is that this X will buy a computer. That is in naive Bayes. So we compute, yeah, we compute all the a priori probability and also the posteriori probability. Yeah. How about in decision tree? Yeah? How about in decision tree? Okay. This one. So based on this training data, yeah, the decision tree algorithms developed by Queenlands, yeah, will develop this tree. Yeah, will develop this tree. Once this tree develop, then this tree can be used for predicting the customer. Yeah. So for example, previously here, right? Hmm. Age less than or equal 30, income equal medium, shouldn't equal yes, credit rating equal fair. Okay, now how this model can predict whether X will buy a computer or not? So we just trace this decision tree starting from the root. Yeah, starting from the root. The root is age. Age less than or equal 30, right? Yeah. So from this node, we go to the left, right? To the left, right? Because less than or equal 30. If age is between 31 to 40, this will go to this path. If age greater than 40, then it goes to the right path. Because X has the age less than 30, then we go to the left path, which is this one. Next, asking about student. Is X student or not? So based on the attribute, student is yes, right? Student is yes. Student is yes. Then because student is yes, then it go to the right path, yeah, to the right path. And we come to the leaf. This is leaf. Leaf is the node in the decision tree that doesn't have children. Doesn't have children. And the conclusion is yes. If we arrive to the left, if we arrive to the bottom, to the leaves, then the conclusion is yes. Yes mean yes, X will buy computer. So this decision, yeah, the decision as the result of the decision tree, yeah, and the decision of the result of the knife-based algorithms, that is the same in this case. So based on the decision tree method, yeah, X also will be predicted as by computer. Just like knife-based also predicting that X will buy computer also. Understand all of you?
Question, sir.
Yes?
Yes. In this example, we start from the age and so on and so on. So, is there any particular method? How do we choose which one is the first to from this method? I mean, from the decision tree method, sir. I mean,
Okay,
can we
yeah.
start like from income or the status or credit ratings, or is it should be from the age? Is there any reason for it?
Okay, yeah, like this. So previously, yeah, I explained to you how to use this model, right? How to use this model, yeah. And the question is that, yeah, where this decision tree come from? Yeah, where this is, as your question, yeah, the root can be age, right? Can be age, can be income, can be student, can be credit rating, right? Yeah, this one. Why we choose age here? Yeah? Why we choose age here? Actually, as the root, this can be age, can be income, can be student, can be credit rating, can be. But we must have the algorithms, yeah, how to make the good decision tree. What is good decision tree? Yeah? Okay, because there is no in the slide, yeah, I will write it. What makes the good decision tree? The good tree, I mean. Yeah. First, yeah, the the number of levels in the decision tree must be balanced. Balance. So the deep, yeah, number of levels, it is also called uh, the depth. Yeah. The depth of the decision tree must be balanced. What is the meaning of balance? Yeah, like this. Yes. Actually, yeah, from the root we have three subtree right here. Three subtree. Yeah. The level is from age go to student, right? This is two level. Age student. And the second one, it is only one level, and the last one, this also two levels. Yeah. it means that balance. Balance means all have the same level. If the left subtree is 5 level, so the other subtree must have also 5 level or 4 level, yeah. Maybe the difference only 1 level, it's okay. But it cannot have the very long gap, yeah. The very different gap, it cannot. Yeah. So for example, in the left we have 10 level, but in the right we have only 1 level. That is not balanced. Yeah. So this is the example of the balanced tree, right? Yeah, the depth of this tree is 2 or 1 only. Okay, so the number of level has to be balanced, and the tree has to be shallow. The tree has to be shallow. Why it has to be shallow? Because if the tree is shallow, so the searching time will be reduced, right? Yeah. So imagine if the number of level is 10 level. 10 level, so we have 10 steps, right? To arrive to the leaf, to arrive to the conclusion. But if it is only 2 level, so we just need 2 steps, yeah, for searching. Understand? Yeah. Okay. So the criteria to make the good decision tree, the first one, the decision tree must be balanced, yeah. And number 2, the tree has to be shallow to make the searching of the decision is faster. Yeah. Okay, so actually you can randomly, yeah, you can what use the brute force algorithm. Brute force means try one by one. Try one by one. Try you develop the decision tree, yeah, but the root is income, and the root is student, and the root is credit rating. You can try develop your tree. This will be the best one. This will be the best one. Understand? So this will be the most shallow tree and also the most balanced tree. Yeah, this one.
So, in other words, to decide which one will be the root, we trial and error, yes, sir, to see which one is the best.
Uh, the question is how to how to how can we find the best one without trial and error? We try without trying one by one because we have so many based on this training data. We have so many trees. Yeah? At least we can develop 20 different trees based only this training data. Because you know that as the root, it can be age, it can be income, it can be the student, it can be the criteria. That's already 4 possibilities as the root. Once we choose one attribute as the root, then the children also can be anything, right? For example, after we determine age as the root, then the children of the age can be income, can be student, can be credit rating, right? Once the child is students, we choose students, then the children of the student can be income or credit rating, right? So there's so many possible tree, yeah. So based on the permutation, yeah. So for the root, we have 4 possibilities, yeah. For the next children, we have 3 possibilities. The next children, we have 2 possibilities. And the last one possibilities. It means that the possibility is 4 multiplied by 3. Yeah. So maybe I will write it. The number of the the number of the possibility tree, yeah, that we can develop from the training data is 4 multiplied by 3 multiplied by 2 multiplied by 1. How many is this? 24, right? 24 different 3. So from that training data, yeah, the one that we exercise in Bayesian method, yeah, so we can make 24 different trees. Yeah. If you do it by trial and error, yeah, try one by one, yeah, then it takes time, right? It takes time. Even computers will take time. Computers. Do you want to develop these 24 different trees? Yeah. I think you need around 3 hours, yeah, to create that one. So don't do trial and error. Don't do trial and error. So that's why Queensland, yeah, Queensland researchers from Australia, yeah, Queensland still alive, yeah, still alive until now, because ID3 is developed in 1980, yeah. You know that machine learning field, yeah, is the very new field in informatics or in computer science. Yeah. Queensland developed the algorithms that without creating one by one, without try one by one, yeah, we can just develop the best tree for that. So Queensland give the name of the algorithms. Yeah, for the first time it is called ID3. Yeah, ID3. And then Queensland improved the ID3 become C4.0. Queensland also revised the algorithm C4.5 and then C5.0 and the latest one C6.0. By following the Queensland algorithms, from this training data, you and also computer can directly develop this tree. Understand? How to do that? Okay, today we learn it. Today we learn the Queensland algorithms ID3. Yeah, how the computers can by once, yeah, create the best tree, yeah, without creating one by one the tree. Understand all of you?
Sorry question,
Yeah.
Abung Sir.
Yes.
Uh, I think X is for variable. Age, income, student, and credit rating. But the three only age and student. Why?
Hmm.
Why only two?
Yeah. Because if we already know the age and we already know the students, we don't need credit rating anymore. We don't need what? We don't need income anymore. We don't need it based on this training data. Based on this training data. That's the beautifulness of this algorithm. If the attribute not needed, yeah, why we should add that attribute? So based on this training data, yeah, the Queensland's ID3 algorithms, yeah, will just use the the attribute age, student, and credit rating here. Income never use at all here. And also, if we already have the age going to the left, we need only age and student. Even in the what's in the middle, yes, age. We didn't just age. If age from 31 to 40, it is yes by a computer. Why? Because here is, look at the training data. Look at the training data. Look at the customer that has the age from 31 to 40. What is the decision, by a computer or not? Here's in the training data.
Yes.
By a computer, right?
Yes.
Yes. Every customers from 31 to 40, the age is 31 to 40, all by computers. No any single customer with the age 31 to 40, not by computers, all by computers. So that's why if next come to my shop, a customer at the age is 31 to 40, based on the training data, this has to be by computer. All right? So we don't need to ask income, we don't need to ask student, we don't need to ask credit rating. Because in experience, all the past customer that has the age between 31 to 40 by computer. Understand? That's very logical thing, right? Very logical thing. Understand all of you? Understand the one that asked?
Yes, sir.
Yes, yes. What for? Based on the training data, all the customer that has the age between 31 to 40 by computer. Okay, just like this, for example, uh, you know the rule in Persian University? In Persian University, yeah, if you want to graduate, you also, yeah, master student also including, yeah, in that rule. When you want to graduate, you have to submit the TOEFL what? TOEFL, the result of the TOEFL test. Can be TOEFL, can be IELTS, etc. like that. And there is a minimum score, yeah, minimum score. If your minimum scores below a standard in Persian University, you cannot graduate. Remember, even though you already passed your your subject, you already also have the final thesis examination, the defense. Yeah. But if you cannot prove that your English is not good, yeah. So in the TOEFL test, what's the minimum? I forget, yeah, the minimum. There's a minimum value of the TOEFL. Yeah. So you cannot graduate. Do you know about this rule? All of you?
Yes, sir.
Yes, sir.
You know, yeah. So you have to prepare. But in Press University, yeah, if for example there is a student, yeah, the student, the nationality of the student is United States, for example, United States or United Kingdom. So they don't have to take a TOEFL test. So Press University will not ask about the TOEFL test. No, there is no TOEFL test requirement. Why? Because the nationality is United States, right? Elementary school in United States, junior high school in United States, high school in United States. So we should ask the TOEFL value. He or she is native English speaker, right? Yeah. So we don't need it, right? Presidency doesn't need it. Yeah. Doesn't ask that students, yeah, to where is your TOEFL score? Yeah. No. Understand all of you. What for? And also, if a student, the master degree students, working in a company, yeah, but that company use English in everyday language, yeah, as the everyday language, then you don't need also to take TOEFL, yeah, or to take IELTS score. Yeah, no. What for? Every day using English, right, in the company. So there's some exception, some exception. But if you don't work in English speaking company, yeah, or you don't the native what's the talk of your language is not English, yeah, then you have to take TOEFL, IELTS, or similar things, yeah, to show that you have the proficiency in English. Understand? That is the analogy, yeah, for this. This is the analogy. All the past customer that has age between 31 to 40 will always buy a computer. Yeah. Will always buy a computer. So why we have to ask, are you student? Are you student, yes or no? Your income is high, medium, or low? Understand, yeah, all of you? Okay. Now, how the Queen's ID3 algorithms can develop this one? Can develop at once the best tree based on the training data. How to do that? That algorithms that we will learn, yeah, today. But before we learn the Queen's ID3 algorithms, you need to know one of the concept, yeah, called entropy. Entropy. Because the Queensland's algorithm is based on the entropy concept, yeah, the entropy concept. What is the entropy? Yeah. What is the meaning of the entropy? The entropy is to measure, yeah, the uncertainty of the situation. The uncertainty. If the entropy is higher, then the uncertainty is also higher. When the entropy is lower, then the uncertainty is lower. That's the concept of uncertainty. So the value of the uncertainty is the lowest is 0 and the highest is 1. The highest entropy, 1, it means that we can never take the decision because it's very uncertainty. Yeah. So for example, I ask you, yeah, if I said that tomorrow, yeah, tomorrow morning the sun will shine. Tomorrow morning around what? Around 5:30 a.m. Yeah, the sun is what? Will the sun will rise? The uncertainty is low or high there.
Hmm.
The uncertainty is low or high. Tomorrow the sun will rise.
Fine.
The uncertainty, the
High.
uncertainty is
Low.
high,
Low, sir. Low.
low, yeah, low,
Low.
low. It is very certain, right? It is very certain that tomorrow the sun will rise. So lower uncertainty. That's lower uncertainty. Yeah. Now I ask you, yeah, you will go to heaven or hell after
Heaven,
the Armageddon? You will go to the hell
or you will go to the what? To the heaven. What do you think? The uncertainty is high or low?
50-50, sir.
50-50. If 50-50 means that the uncertainty is high. The uncertainty is high if it is 50-50. If you said that I definitely go to the heaven, so it is low uncertainty, low. If definitely, on the contrary, definitely I will go to hell. I will go to hell. It is low uncertainty. Yeah. I'm sure I will go to heaven. So low uncertainty. I'm sure I will go to the hell because I am the bad person. I do any bad things, for example, like that. That's low uncertainty. If you said, sir, 50-50, sir, maybe if I got the mercy from God, I will go to the heaven. If I don't get God, I don't get mercy from the God, then I go to the hell. It means that that is the uncertainty is high. 50-50 is the very highest uncertainty. Understand the concept? All of you?
Can you
Yes,
The
sir.
repeat
highest,
again, sir?
yeah. Yes?
Could you please repeat
Understand
it
it?
again, sir? I'm still not quite understand.
Okay. Uncertainty means, yeah, uncertainty. Actually, that is the what? We never sure, yeah. We never sure, yeah. Whether we are in a certain conditions or with other condition, yeah. That is called uncertainty, yeah. So for example, like this, yeah. Uh, for example, maybe like this, yeah. What's yeah? Maybe I will explain again with the analogies of the everyday life, yeah. Okay, I repeat again about going to heaven and going to hell. If you are sure that you will go to the heaven, then the uncertainty is low. Understand? I'm sure
Yes,
I
sir.
will go to the heaven. Uncertainty is low. How if I'm sure I will go to the hell? I'm sure I will go to the hell. Is it low uncertainty or high uncertainty? I'm sure I will go to the hell. Is it
Low.
low or high uncertainty?
Low,
Higher.
sir.
Yes,
Low.
low uncertainty. Low uncertainty. But if you said, oh, I don't know, sir, I don't know. I don't know whether I will go to heaven or I will go to the hell. I don't know. Why? Because sometimes I do bad things. Lot lot of bad things I did. But sir, I also did good things, sir. So I don't know, sir. It is based on the what's the mercy of God. 50-50, sir. 50-50. So is it low uncertainty or high uncertainty?
Hi, sir.
High.
Hi.
High uncertainty, yes. 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 Understand about the concept of uncertainty.
Understand, sir.
Hmm. Okay. Uh, understand ya, all of you, with this example? For example, Bruri. Bruri here.
Yes, sir.
What is your? I forget. Last week you said to be your favorite actress.
Taylor Swift, sir.
Oh, Taylor Swift. Okay, Taylor Swift. Okay, all of you. Now I ask to you, yeah. I ask to you, yeah. I ask to you. What's the favorite of Bruri's actress is Taylor Swift, yeah. Taylor Swift. When Bruri wants to express his love to Taylor Swift, Taylor Swift, yeah, will accept or not, yeah, the love expression from Bruri.
No, sir.
The uncertainty is low or high.
Higher.
The uncertainty.
High.
Very high. High, sir.
Uncertainty is very high.
Very high.
If you said that the uncertainty is very high, yeah, it
Low,
means
sir.
that Taylor Swift 50-50 will accept what Bruri or not. Is it? if I if I can judge, yeah, the uncertainty is very low, not high, very low. Why the uncertainty is very low? Because we know that Taylor Swift will reject Bruri's expression of love.
Mm.
Anybody of you think Taylor Swift will accept Bruri's love to Taylor Swift?
Of course not, sir.
Huh?
Definitely not, sir.
Definitely not. Yeah, definitely not. You said that. If definitely not, then it is low uncertainty. Low.
Okay.
Remember.
Even I already showed the
Yeah.
love, yes, sir.
Yeah. Low, right? The uncertainty is low. Because we know that definitely no uncertainty at all. Very certain that Taylor Swift will reject. Bruri, no offense, yeah, Bruri.
It's okay,
Bruri.
sir.
Just kidding. And also, actually, you don't expect Taylor Swift love, right? And some of you, please don't confuse. Yeah? Some of you still confused. You said that, oh, high uncertainty. High uncertainty. You know that high uncertainty, if it is only 50-50. If the chance is 50-50, the uncertainty will high. Uncertainty, yeah, different from probability. Different from probability. Maybe you mix it with probability, yeah, with probability.
So still confused between the probability and uncertainty in terms of 50-50, sir.
Mm. Oh, 50-50. Okay. Maybe I will write here. Yeah, like this. Uncertainty. The concept of uncertainty actually is, yeah, we never know. We never know. Yeah. We cannot have decision or confusing. Yeah. So this is the antonym of certainty, right? Certain. The certainty. Certainty is, yeah, no confusion at all. everybody already know. Yeah, that's the meaning, yeah, uncertainty. Okay, like this, yeah. Okay. So first of all, previously, yeah, Taylor Swift will accept Bruce's love or not. Yeah. Can you give the decisions? Taylor Swift will accept Bruce's love or not? Based on this condition, it is very certain, right? It is very certain that Taylor Swift will reject. Will reject the Bruce's love. Very certain, right? Very certain, right? Yeah.
Yes.
So that's why it has low uncertainty. Answer or not in this situation?
Yes.
It has low uncertainty, right? Yeah, like that. And because we know that Taylor Swift will reject. Maybe if Taylor Swift accept Bruce's love, that's a miracle. A miracle, maybe. Yeah, low uncertainty. But if you say, that the probability of Taylor Swift love is 50-50, 50 means 50%, yeah, 50-50, then it is high uncertainty. Answer all of it now?
Yes, sir. So the concept of entropy is not talking about the probability, yes, sir.
No, not relating to probability, but relating to uncertainty.
Yeah, black or white.
Mm.
Something already clear. Yeah. Okay.
Yes.
Thank you, sir.
Yeah. Okay, now I will ask you again. Yeah? I will ask you again. So check whether you already understood or not.
Question.
Yes, question, yes.
Yes. For example, if let's say in our data set, it
I cannot hear you,
includes.
yeah? Sorry, I cannot hear you.
Hello.
Yeah?
Can you hear me? Yeah.
Yes. Oh,
So,
yes.
for example, one features of our data set not categorized in any decision. I mean, not for example in your example like buying or not buying computer, but in the data set there is some features that it doesn't include anywhere. so is also defined as uncertainty, or how is it, sir?
Oh, okay. That's different thing, yeah. That's different thing, yeah. I will explain later about that.
Okay. Oh,
Yeah.
right.
Yeah. I just want to introduce you the concept of uncertainty informally. Informally, yeah. This informally. This is actually the informal definition, yeah, not the formal definition. So to make sure that you understand the concept of uncertainty, yeah, uncertainty. Okay. Okay, if you understand it, the uncertainty informally, yeah, then now I will explain you the concept of the entropy, yeah, formally. Yeah, the entropy of the condition. Okay, maybe I will give example the informal, yeah, the informal definition. Ini, for example, what's now in Jakarta, yeah, in Jakarta, in DKI Jakarta, we have 3 candidates, right, as the governor, yeah, Ridwan Kamil. Who's next? The competitor is
Pramono Anung.
Pramono Anung, yes, Pramono Anung. Pramono Anung. Okay. What is the probability of Ridwan Kamil win the election, the DKI Jakarta election? What's the probability? Pramono Anung win the DKI Jakarta election. What probability?
One more, sir.
Oh, one more. Oh, yes,
Yeah.
one more.
Pak Dharma Pongrekun.
Pak Dharma, ya?
Dharma.
Ya. Oke. Pak Dharma, the probability of Pak Dharma win, ya. Win the DKI Jakarta election.
One third?
Huh?
The probability, 33%, one third for each?
One third you mean? Okay. If you said that the probability, no, the probability, it depends. It depends on the popular vote of Ridwan Kamil, Pramono Anung, and Dharma. You know that Ridwan Kamil now supported by how many political parties?
So many, sir.
So many, yeah. All right, yeah. All except PDIP, right? Yeah. So the probability maybe I don't know. Maybe it will be higher, yeah. Maybe 85%. And for example, yeah, Pramono Anung, maybe, yeah. This is just just a game, yeah, game, just guessing, yeah. This is 10%, for example, yeah, 10%, and this is 5%. If the situation like this, yeah. So who candidate that will win the DKI Jakarta election if the situation like this?
Ridwan Kamil.
Ridwan Kamil, ya, Ridwan Kamil,
Yeah, probably Pak Ridwan Kamil.
Yeah. So this situation has high uncertainty or low uncertainty?
I think high.
Low
Low
uncertainty.
Low.
Low uncertainty.
Low, because definitely Ridwan Kamil will be elected. Yeah.
I'm sorry to interrupt, but why not one that because that's the best probability, and then with the condition, I think the condition of the party is the condition, so it will become 85. It's because the condition, but the best probability, I think it's 100.
I'm sorry, your voice is very low. I cannot hear you.
So the base probability, I think it's 1/3 or 33% for each candidate, and the probability will change because of the condition.
Yes.
This condition is party, I think.
Yes. Based on the condition, right?
Yeah.
Yeah. Based on the condition, yes, of course. So the situation has low uncertainty. Yeah. It means that low entropy. Understand? If this the situation. But if the situation is like this, probability of Ridwan Kamil elected is 33%. Pramono Anung is 33%. Dharma is 33%. If the situation is like this, can you decide who will be elected? Ridwan Kamil, Pramono Anung, or Dharma? Can you decide it?
No one.
It's
No one,
difficult.
sir. Yeah, it's difficult.
Difficult, right? That's difficult. Difficult. This one. This. We never know. We cannot have a decision. Confusing. That's right. Confusing. We never know. We cannot have a decision like this. So this will be, it is called high uncertainty. So it is high entropy. High uncertainty. We don't know. We never know. Like that. Understand now?
Understand, sir. Thank you.
Yeah.
Sir.
Yeah. So high entropy, high uncertainty. Yeah. What if Ridwan Kamil definitely will become the next governor? Yeah. Then it is low uncertainty, low entropy. Understand now, yeah? Okay, yeah. Okay. Now we define the entropy formally. Yeah. What is the entropy actually? Yeah. The entropy formally. Yeah. The entropy is if we have three distinct value. Yeah. If you have random variable y taking m distinct value, y1, y2, ym, y can be, it depends on the situation, can be what? Ridwan Kamil. Y1 is Ridwan Kamil elected, y2 is Dharma elected, y3 is Pramono Anung elected, for example, elected. So the condition, the situation, the entropy of the situation is minus pi log pi. What is pi? Probability. Minus pi log pi. And then we sum it up. So in this situation, so what is the entropy in the above situation of DKI Jakarta election? Based on the formula, so
is the entropy of DKI Jakarta election is minus probability Ridwan Kamil win is 33%, right? So 1/3 multiplied by logarithmic of 1/3. Like this. Minus 1/3 this is for Ridwan Kamil. Yeah. This is for Pramono Anung elected. And this is for Dharma elected. That one. Understand how to compute? All of you understand?
Yes, sir.
If you compute it, yeah, can you guess what is the value? You can try your calculator. You can try your Excel. Yeah. I can calculate it without calculators, without Excel. This will be 1. Highest entropy. Highest entropy. You can calculate it using Excel. Entropy is always from 0 until 1. The highest one is 1, and the lowest one is 0. In these situations, the entropy value is 1. You can calculate it. Anybody already calculate it? It will be 1. Understand all of you how to compute?
Yes, sir.
But, yeah.
Question, sir.
Yes?
If the score is 0.5,
Mm-hmm.
so what is the status of the entropy? It is
If what?
high or low? If the score is 0.5, for example.
Uh-huh. The
You
score of
said
entropy,
that,
you mean?
yes, yes. Is
Yes,
it,
your question?
so you said that you explained that the score of the entropy is between 0 to 1.
Yes.
1
Yes.
is the highest.
Yes.
In case if the score is 0.5,
Mm-hmm.
is it high or low? The score of the entropy.
Oh, low and high, yeah, that actually what's actually doesn't if it is 0.5, yeah, 0.5, it means that it's not low, it's not low, it's not high, right? Yeah, it is in the middle.
Yes. Yes, sir.
We cannot say it is low entropy or high entropy. Cannot, right? Because it is in the middle.
Is it possible we will find this situation?
Yes, yes, possible. Yes. So every entropy value are possible happen from 0 to what? To 1. It's possible happen. It's possible happen. It's possible happen.
And in terms of uncertainty or certainty, is it high certainty or low certainty?
What for? What for?
If the situation of the entropy is in 0.5.
The concept of entropy usually, actually, yeah, is not based on low and high, no, but it is on the comparison, yeah, comparison. So, for example, entropy 0.4 and 0.3, yeah, this one, yeah, 0.4. So, for example, entropy condition 1 is 0.4 and entropy condition 2 is 0.3. For example, yeah,
Mhm.
which condition that has higher entropy? Oh, sorry, higher uncertainty.
Oh, okay, it's apply not in solo case, sorry. So it is not apply or implemented in solo case, then we should, it will apply for at least two conditions, right?
Yes, two condition, yes.
Okay. Okay, I got it.
Entropy is for comparing, yeah, comparing,
Yep.
for comparing. So which condition that has higher uncertainty? Which condition? Condition 1 or condition 2? Entropy condition 1 is 0.4.
Condition 1, sir.
Yes,
Condition 1.
yes, like that. Yes, like that. Okay. What do you like? What do you like in life, for example? In life, for example, yeah? You want to have the high uncertainty or low uncertainty?
Low uncertainty.
Low uncertainty.
Yes, of course, yeah. Which one is better, low uncertainty or high uncertainty?
Low uncertainty.
Low uncertainty is better.
Yes, that's correct. Right? That's correct. Low uncertainty is better, right, than high uncertainty. Understand? Anybody have other other opinion? Sure. For me, high entropy is high uncertainty is better than low uncertainty. Maybe the one of you that have what adrenaline, what mentality, yeah, maybe. Also, for me, high uncertainty is better because make my adrenaline is higher. Yeah, maybe, yeah. But in general, lower uncertainty, yeah, it's better, right? Like in general, right? Anybody love high uncertainty?
But there is an adagium that the certainty is uncertainty, sir.
The uncertainty is low. It is better. Maybe I'm right. The lower uncertainty, the better. The lower uncertainty, the better. The lower entropy is the better. Understand, eh?
Understand, sir.
Yeah. And now, because I already introduced you to the formal definition of entropy, is it understand how to compute it? Understand or not? Understand?
Yeah, in this simple example, so far I understand.
Okay, how if I write like this? Okay, other situation. This is, for example, what 75%, and this is 15%. This just example, yeah, because uh, I never interested in politics, yeah. So I'm not affiliated with one of the candidate of the governor of DKI Jakarta. 10%. Yeah. Now compute the entropy of DKI Jakarta election situations if the situation like this. Compute it. This will be what is this value? 0.7?
7.5.
7.5.
And this is 0.
0.75.
0. What?
7.5.
0.75. How about here?
0.15.
Yeah.
No, here. Yes, 0.515
Yeah, the second one.
multiplied by log 0.15.
0.15.
Now what in here?
0.1.
0.1.
Yes, 0.1 log
0.1.
0.1. And result is, now I cannot predict it. You have to do calculator. You have to use calculators or Excel. Understand, yeah? All of you?
Yes, sir. Understand.
Next example. This situation. Ridwan Kamil is 100%. 0%. And this is 0%. Can you guess what is the entropy of this situation?
0, sir.
Without using the formula, can you guess what the result? Entropy?
0.
1.
1.
It's -1.
Yes.
There is no
Zero.
minus one. There is no minus one value. Entropy is always
0.
0 to 1. Entropy. No
One.
minus. From 0 to 1.
1.
It's
1.
1.
All of you,
Yeah.
1.
1.
1. Okay? All of you is 1?
0, sir.
The answer is 0.
I think 0, sir. Yeah.
The answer is 0.
Low uncertainty.
Do you have uncertainty
Because it's
here?
very
Do you have
certain.
uncertainty?
No.
It's very
100%.
certain.
Very certain. Why you answer 1? How come? 1 is the very high uncertainty. Yeah, 1. No uncertainty at all, right? 0. It definitely Ridwan Kamil will be elected, right? No, any single uncertainty, no. Even 0.000, no. Ridwan Kamil elected. Every situation, yeah, like that. And some of you? Oh, some of you still confused?
Understand,
I
sir.
get it now, sir. Thank you.
You get it now. If you don't believe it, compute it using the formula, yeah. If you what? If you don't believe it, yeah. Oh, Surila guessing without computing the formula. How come Surila said zero? Yeah, because no uncertainty at all. No uncertainty at all. If you don't believe it, calculate it now. Calculate it, yeah. So for Ridwan Kamil what? 1, right? Oh, sorry, minus 1 multiplied by log what?
Log
Log
1.
Log 1, yes, yeah. And then now for Pramonanung is,
0.
what is the probability?
0.
0, sir.
0, right? Multiplied by log
Log 0.
0, yes.
Log 0.
Uh, and then next, Dharma probability is 0 multiplied by log
Log 0.
0, right? Yeah. Okay, finish. Compute now. Equal, yeah, minus 1 multiplied by, what is log 1?
0.
0, yeah.
0.
Minus 0 multiplied by anything will be
Will be 0.
0.
0. Next, for Dharma, 0 multiplied by anything
0
will
also.
be 0. So, equal 0 minus 0 minus 0 equal 0.
Oh, yeah.
Understand all of you?
Yes, sir. Understand.
Understand, sir.
Yeah.
Yes, sir.
Yes. Don't be confused again, yeah. If no uncertainty at all, the entropy will be 0. Yeah. If definitely uncertainty, we cannot decide it yet, yeah, then it is 1. Yeah, it is 1. Understand now the concept of entropy? Yeah. Okay, back again to my slide. Yeah. Okay, like this. Yeah. So this is the what? Hmm. So we have the graphics. Yes. Yeah. The y-axis is entropy. Yeah. And the x-axis is probability. So if we go from left to the right in the x-axis, yeah. So the graphic of the entropy will be like the curve like this. The curve like this. So if probability is 0, the entropy is 0 because no uncertainty at all, right? No uncertainty at all. So going to the right, yeah. So the curve will be higher, including 0.5, higher, and the highest one, 1.0, is when the probability is 50-50. If 50-50, 0.5, this will be the highest. And then if the probability more than 0.5, then the value of entropy will be lower, and get the entropy 0 if the probability is 1.0. Because probability 1.0, it means that no uncertainty at all. Understand? So tomorrow the sun will rise. Yeah. The sun will rise. The probability is 1, right? Anybody said that? Oh, so no, probability is 50-50, sir. If you don't consider the Armageddon, yeah. If tomorrow Armageddon, of course, the sun will not rise. The Armageddon. Yeah. But if it is not Armageddon, then probability is 1. Tomorrow the sun will rise. Because probability 1, then entropy is 0. Entropy, no uncertainty at all. Okay? No uncertainty at all. Understand the concept of entropy?
Understand, sir.
Anybody that's still confused?
Sir, can you just share the file that you write into to the group?
Okay.
The first file.
The slide you already got it, right? The slide is you already got it, right?
Yeah, sure.
Yeah, the slide. Okay. The class note, yeah. I will send to you the class note. Okay. Next. Nah. So what's the decision tree algorithm ID3, yeah, and also C4.5. This is founded by Quinlan, yeah, Quinlan. So it is based on the entropy, yeah, based on the entropy. So how to use it, yeah, how to use it, yeah. Okay, like this, yeah, previous one. We have the training data, yeah, we have the training data like this. Yeah. We have to choose which one become the root. Age, income, student, credit rating, or bias computer. Sorry, not bias computer, yeah. Bias computer is the target class. Among these four, yeah, the first, the root, yeah, has to be age, income, student, or credit rating. The attribute that chosen by the Quinlan ID3 algorithms is the attribute that will reduce the entropy value. Will reduce entropy value. Reduce entropy value mean reduce uncertainty, right? Reduce uncertainty, right? If age reduce entropy highest, then age will become the root. If income will reduce the entropy, the highest one, the root will be income. If student give the reduce the highest reduce entropy, student will become the root. So to choose which attribute that will become the root, then we have to compute the entropy of all the training data, and we compute the entropy of age, we compute the entropy income, we compute the entropy student, we compute the entropy credit rating. The attribute that give the highest reducing entropies, that will be chosen as the root. That's a logical way, right? That's a logical way. Can you accept the logic? We want to have the uncertainty is low, right? Become lower, 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 and lower, right? Yeah. We want to have the entropy become lower, 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 and lower. So we choose the attribute that will make the entropy become lower, lower, lower in the training data. Okay. Now, from this training data, yeah, from this training data, we have to compute the entropy of bias computer yes and bias computer no, right? Because the target is by computer no or by computer yes, right? So we compute the entropy, yeah, of all the training data. From the training data, what is the probability that the customer will buy a computer? What the probability? How many customer in the training data that buy a computer? How many?
9.
9. How many all of the training data? How many?
14.
14.
14. So the probability customer will buy computer is
9 divided by
9
14.
over 14.
Yeah.
9 over 14. Understand or not?
Yes, sir.
Okay. How many customer that not buy computer? How many?
5.
5,
5
right?
divided by 40.
So the probability that the customer will not buy computer is 5 divided by 40.
14.
Uh-uh. So the entropy of this all training data, the entropy of all training data, the uncertainty is minus 9 over 14 log 9 over 14 minus 5 over 14 log 5 over 14. Actually, the basis of the logarithmic can be 2, can be 3, can be 10, yeah, like that. But because we use computer usually what's faster if the basis is 2. Why? Because our computer is digital, right? Based on the digital circuit, yeah. So that's why it is faster if we take the log, the basis is 2.
Binary, yes, sir. Because of this binary.
If you do use calculators or Excel, then the result is 0.940. Understand about this? Understand or
Yes.
not?
Understand, sir?
Understand, yeah.
Between two.
So the entropy of the training data is 0.940. This is high or low entropy?
High, sir.
High
High, right?
uncertain.
Close to 1.
Close to 1.
Close to the maximum 1. Yeah. It's high. That's why we have to reduce, right? We have to reduce the entropy. This is very high entropy, high uncertainty. To reduce the entropy. Now we compute the entropy. How reduce the entropy if we take the age as the root, if we take the income as the root, if we take the student as the root, if we take the crediting as the root. Answer there. Okay, now we try to compute the entropy the entropy if we take the age as the root if we take the age as the root. Okay, if the basis is age if the basis is age, how many possible value in age? How many possible value?
3.
3 possible value, right? 3 possible value, which are what is it?
Low, medium, and high.
Age,
Eh,
age.
Under equal 30, 30 to 40, more than 40.
That's correct. Yeah, that's correct. So we have 3 possible value of age: under 30, between 31 to 40, and greater than 40. Now we compute the uncertainty or the entropy of each possible value for each possible value. So we have 3, right? 3 possible value. Now we compute for the first value, which is under 30. In under 30, how many customer that buy computer? The customer that under 30, how many customer that buy computer? How many? Please count it.
Two, sir.
Two.
2 students.
Two, right? Two. And the customer which age under 30, how many customer that not buy computer?
3.
Three.
3 students.
Three, right? Three. So the entropy is what? The entropy is the entropy of uh, age less than or equal 30 is, compute it. How to do that? What is the probability that age
2/14.
huh? Probability minus how many that by computer? How many?
2/14.
2 over 14, sir?
No,
Or
2
2 over
3.
5?
2/5. Yes.
Oh, 2 over 5.
Yeah.
Oh, amongst under 30. Okay, sir.
Multiplied by log
Log
what?
2 over
Log
5.
what? 2/5.
2 over 5.
That is by computer, right? How about
Yeah.
not by computer?
Minus 3 over 5
Yes, that's correct. Yeah.
times log
Multiplied by log.
3 over 5.
Yeah. Understand or not? This calculation. Anybody that's still confused, please ask me before we go further. Understand ya?
I understand,
Yes,
sir.
sir.
Okay. Yeah. Now I ask you, how many customer that under age 30 overall? How many customer that under 30 overall? How
5,
many?
sir.
5.
Five.
5.
Five, right? Five, yeah. So the probability of entropy of age under 30 is how many? Probability of under 30? That is what? That is 5, right? 5. 5 over 14. Like that. This is the entropy of age less than or equal 30. And this is the probability of the age under 30 among all three data. Understand or not? Next, we compute the entropy of age between 31 to 40 is okay. Oh, sorry. Please compute how many customer that has age between 31 to 40 that buy computer.
4.
4, yeah.
4.
Yes. How many customer that have age between 31 to 40 that not buy computer?
There is no zero.
Zero.
Zero, sir.
Zero. Yes, zero. So please compute the entropy here. Okay, I just become the writer, yeah. You said the formula.
Oh, the entropy first.
The entropy
Okay.
4
For
4
4.
divided
over
by what?
4/4, sir.
4.
Yes, that's correct. That's correct. Okay.
Multiply
4 divided by 4
Multiply by
Multiply
log
log 4
multiplied
over
by log.
log
Remember,
4 over 4.
4 divided by 4. Yes. Minus customer that not by computer.
0.
0
0 what? 0 over?
over 4.
4
Yeah. 0 over 4 multiplied by
multiplied by
log
log
0 over 4.
0
log
0
0 over 4.
4.
Okay.
that is 9, sir. 0.
That's 9, sir. Should be 0.
Understand ya, Taufik?
Uh,
Next. How many the customer that has age 31 to 40? How many?
4
4
over 14.
4 over
14.
14.
multiplied by this one. Like this.
Sorry, sir. The last log is log 0, not 9.
Oh,
0
sorry, yeah.
over 4.
Typo,
not 9.
typo, yeah.
Yeah,
Sorry.
typo. Sorry.
Typo. 0.
Yes,
Yeah.
sir. Thank you.
Okay, now the entropy of age more than 40 is okay. Take a look at the training data. Yeah. How many customer more than 40 that buy computer? How many?
3.
3, right? Yeah, 3. How many customer that has age more than 40 that not buy computer?
2.
2, right? Yeah. So 3 by computer and 2 not by computer. So please compute the entropy. Minus what?
3 divided 4.
5. 5.
Minus what? 3 divided by 4. Really? Really?
5.
How many? How many? All the
5, sir.
5.
5.
how many customer?
5, sir. The
5
customer
customer.
more than 40.
5. Why you said 4 previously? Why you said 4? 5, right?
5, yeah.
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 5.
Multiply by
Multiply
log
log
By
3
log
over 5
yeah.
3 over 5, yeah.
5. Yes.
minus
Minus what? Minus what?
2
2
over 2
over 5.
over 5.
Yes, that's correct. Yeah.
Multiply
Multiply
by
Multiply
log 2
log
2
2
over
over
5.
over 5.
5.
yeah. That's an entropy, right? Yeah. Now we compute the probability of the entropy of H. Oh, sorry, typo again. Not 49, but 40. Yeah.
Yeah, 40, sir.
Yeah. This has to be multiplicated by the probability of the entropy of H greater than 40. How many customers that have H greater than 40? How many?
5
5 over?
Over 14.
14.
Yes, that's correct. That's correct. So the entropy of H the entropy of H is this value plus this value plus this value. Understand? So H, because H is consists of less than 30, between 31 to 40, and greater than 40, then the overall the entropy of H is this plus this plus this. Can you compute it? Can you compute it? You have to use calculator, right? You have to use Excel, right? Because you are not the calculators, you are not computers. Yeah. Your brain is not for calculating something, but your brain, human brain, is for thinking. You cannot compute it very fast, right? But computers doing this is very fast compared to us computer to think. As I said, that computer is just calculating something like that. What is the result? This plus this plus this. What's the result? But I can do it very fast. Yeah, I can do it very fast. Yeah, sorry, I can do it very fast. Yeah. So that will be, yeah, this will be equal 0.964. Anybody can compute as fast as me?
I think it's typo, sir. 694.
Oh, 694.
You
694.
wrote. You said 964. You wrote
Mm-mm.
694.
This is 694. This is 694. No typo.
But you said 964.
964 is. Oh, sorry. Maybe.
Which one is the?
Oh,
which
the
one
typo
is?
is not my writing,
Which one is
but
the
the
correct?
typo is my
Oh,
voice. Yeah.
okay, sorry lah.
The correct one, the one that I type,
Okay.
not the one that I say. Oh, what I say and what I type is different, yeah.
Yes, sir. That's right.
Yeah. Usually typo is writing right now, but this typo is my what I typo. So 0.694, yeah, the result. Why I can compute so fast? Why? Do you want to know the secret?
Because you
You
have
cannot calculate it,
calculated
right?
before, sir.
Yeah. Why I can calculate it so fast? Because it is already written in the slide. This one. This one. This is, yeah. This is already written in the slide. Understand, all of you?
Yes, sir.
Mm-mm. It is written in the slide, 0.694, based on that calculation. Based on this calculation. This one. This plus this plus this. You can try it, yeah, using Excel or using calculators. If you find difficulties or the result is not the same as this, you can let me know. Mhm. It has to be the same. This one. Understand, yeah? Understand this formula? Understand or not? Please ask me questions, yeah, if you don't understand. Don't pretend you understand if you are really not understand. Instead of asking your friends, it's better to asking me. Sir, where this two come from, sir? Sir, four, where this four come from? Understand, yeah?
So far, so good, sir.
Okay, so far so good. Okay, good. Okay, now we already find the the entropy, yeah, the entropy of the age, yeah, which is 0.694. Previously, we already calculated that all the training data, the entropy of all the training data is 0.9940, right? This one, we already calculated it, right? And we already calculated also, yeah, the entropy of the age, which is 0.694. So if we choose the age, yeah, if we choose the age as the root, then the reducing of the entropy is this value, the previous entropy, 0.940 minus 0.694. And the result will be 0.246. Understand? So it means that if we choose the age as the root, then the entropy will reduce from 0.940 minus 0.694, 0.246 will reduce 0.246. Understand all of you? Understand or not? So this is called gain. So the meaning of gain is the value of the reducing entropy that we can gain, we can get. Answer all of you? Okay, next, with the similar way, you compute the entropy for income, and then if you get the entropy for income, you subtracted the value from the 0.940. Yeah, if you compute it later, yeah, this will have the 0.029. And we compute similar thing with the attribute student. And you will gain the gain of the student if you compute it, yeah, that should be 0.151. Then we compute the credit rating entropy, and you will get the 0.048. So which one that we choose? We choose the attribute that give the highest gain, the highest reducing of entropy. Which one is higher? Gain age, gain income, gain student, or gain credit rating?
Gain age, sir.
Gain
Age.
The biggest gain.
The highest one. So the decision is we choose age as the root. Not income, not student, not credit rating, but age. Why? Because the gain that we get is the highest one. Answer all of you?
Is it
Then
the highest or the lowest? Because
The highest gain.
it will be
The highest gain.
reduced by the gain from X, right?
Because there is reduced. The highest one, the highest gain. Not the lowest gain.
Oh,
Understand? So that's how the algorithm of ID3 work. Based on the entropy. Computing the entropy of each attribute. And returns the highest gain. The one that reduces entropy most. Any questions, all of you?
So far, so good, sir.
Okay, good. Yeah. Okay, I will distribute the class note to the WhatsApp group. Okay, now it's already 8:15. 8:16. So I think we will finish our class. Because until 8:15, right? Our schedule. So if you don't have any other questions, so we finish today class. We meet again next week. Next week we haven't have the midterm. Maybe next I will announce it in the WhatsApp group.
Thank you, sir.
Okay, sir.
Okay,
Thank you.
so have a good night, all of you. Bye bye.
Okay, sir.
Okay, sir.
Thank
Thank
you.
you.
Thank you.
Bye.
Have a nice
Thank you, sir.
evening, sir, and everyone. Bye.
Thank you so much.
Yeah.
Thank you.